Hi everyone, I'm Miss Koenig, and this is a quick video tutorial on solving algebraic inequalities. Let's jump in. Let's start with a review of what you should know about inequalities prior to coming into this lesson. You should recognize that an inequality does not have an equal sign. That means x is not equal to 12. It's greater than, it's less than. It could be greater than or equal to or less than or equal to, but not just equal to. In this case, the symbol that you see is less than. That means this x represents anything that is less than 12. It could be 11, 10, 9, 8, but it cannot be 12, 13, 14, 15. When you first learn about inequalities, you typically will learn to draw them on a number line. So let's recall number lines. On my number line, I would put a 12, a 13, a 14, an 11, and a 10. And remember, they should go in number order. They should be increasing as you go to the right side, the larger numbers on the right and the smaller numbers on the left. So if I want to show the numbers that are less than 12, I want to circle the 12, but not fill it in because I'm not saying less than or equal to. If I was, then I'd fill it in. And then I draw an arrow that points to the left side, showing all the less numbers. Here we have a problem that says x plus 3 is greater than or equal to 12. Now, if you are new to equation solving or inequality solving, I suggest drawing a line down that symbol, the greater than or equal to symbol, just to kind of help you recognize that there are two sides to any inequality, a left and a right, and whatever I do to one side, I have to do to the other to keep them balanced. Now, the goal here is to get this x by itself, and I see that the thing with the x says plus 3. I need to use an opposite operation to remove that plus 3, and whatever I do on the left side, I'll have to do on the right. Now, the opposite of addition, of course, is subtraction, so I will be subtracting 3 from both sides. What I'm looking for here is that I'm getting a 0. Positive 3 minus 3 does give me a 0, which leaves me with only the x on the left-hand side. That's a good thing. I'll bring down my symbol, and then 12 minus 3 leaves me with 9. Now, this is my solution to an inequality. It looks slightly different from an equation because I don't have one number that x is equal to. In fact, I have a variety of numbers that x could be. This means that x could be anything that is greater than or equal to 9. Now, in equations, you could plug in a value for x, and if you got an equal value, you knew you had done it right. Let's try a similar method for checking this inequality. I want to find a value that's greater than or equal to 9 to plug back in and just double check that it works. For the sake of ease, I'll choose 10. If I plug in 10 plus 3 gives me 13, which is in fact greater than or equal to 12. You might also choose to plug in not just something that's greater than 9, but maybe you choose to plug in 9 just to make sure it works, because our answer does say x could be a value that's greater than or equal to 9. Now, if I plug in 9 plus 3, of course, is 12. And of course, we know that's equal to 12, so it fits in the greater than or equal to solution. Let's try another. Now, this example should look fairly similar, but just slightly different because I have a 2x this time, instead of x being already a 1x. Again, I'll draw a line down my symbol just to help me remember that there's a left side and a right side, and whatever I do to one, I have to do to the other. Again, I want to use an opposite operation, which means I will subtract 3 from both sides and gives me a 0 on that left-hand side. When I bring it down this time, I have to bring down a 2x, and then again, 12 minus 3 gives me 9. Now this time, I have to think about how to get from 2x to just x. Now 2x means 2 times x, they're being multiplied, and the opposite operation would be to divide. And whatever I do on the left side, I'll do to the right side. In this case, I'm not actually looking for a 0, I'm looking for a 1. 2 divided by 2 gives me 1x, which means I have isolated the variable, and 9 divided by 2 is 4.5. Let's try plugging in a value just to make sure we did the right thing. Here it says that x could be representative of any number that's greater than or equal to 4.5 or 4.5. I'll choose 5 just so we're not working with incredibly large numbers. If I plug in a 5 here, I've got to do 2 times 5 plus 3, which is 10 plus 3 or 13. And again, I've got a value that is in fact greater than or equal to 12. That tells me that we've done this problem right, most likely. This check isn't quite as clear as it is in an equation because we don't have one value for x. However, it does tell us that we're headed in the right direction. Let's try another. This equation says 6 is greater than 7x minus 8. You'll notice that it looks a little different because the core of the inequality is happening on the right side of the symbol instead of the left. Don't let that scare you. It's another look for an inequality. It's another look for an equation. It doesn't mean anything different. It just looks different. Again, I want to isolate my term with a variable, which means I need to remove that minus 8. Because we're using opposite operations, that tells me I need to be adding 8 to both sides. Now on the right-hand side, I know that negative 8 plus 8 is 0, so that's a good thing. That's what we're looking for. I'll bring down my 7x, I'll bring down my symbol, and be careful to bring down that symbol exactly as it is. It's very easy for it to get switched around and confused, and that can lead to an incorrect answer. Then on the left-hand side, I have a 14. Now again, I'm trying to get to a 1x, and I have here a 7x or a 7 times x, so I'll need to use division to get x all by itself. In this case, 7 divided by 7 is 1 or 1x. Again, be extra careful with that symbol, and 14 divided by 7 is 2. Now again, this answer looks pretty different than most of the answers we've seen. It sometimes helps to flip around this answer in order to read it nicely. Often we have that variable going first in our answers. If you want to do that, that's okay, but I would throw an asterisk in there. There's something to be really cautious about. If I flip my answer around, I actually have to flip my symbol to go with it. So you'll notice here that the monster, if you think of the monster or the Pac-Man or what have you, whatever analogy is eating the 2, it needs to be doing the same in this inequality. That's what makes them equivalent answers. Once we've got it written in this form, it's a little easier to read that x is a value that's less than 2. So let's try something. Let's plug something in. In this case, I'll use 0. 7 times 0, of course, is 0. And 0 minus 8 is negative 8. And I know that 6 is a larger value than negative 8. So that tells me that I've done this correctly, or at least that I'm headed in the right direction. Now I want to introduce you to the idea of negatives in an inequality because they change how an inequality works, how it's solved, how it's graphed, and so on. So you'll notice that I have 4 different iterations of comparing 10 and 20. One here, and then we're going to do some math with 10 and 20 just to look at how those negatives interact with an inequality. So of course we know that 10 is a smaller value than 20, so we could use a less than symbol here. But what happens when we multiply by a negative? Here I've got 10 times negative 1 and 20 times negative 1, which of course is negative 10 and negative 20. When we multiply by that negative, our values change. In fact, negative 10 is actually the larger number because it's closer to 0. So you'll notice that when I multiplied by negative 1, my sign flipped. It used to be a less than symbol, now it's a greater than symbol. Let's look at the third row, the division problem. 10 divided by negative 2, I know is negative 5. 20 divided by negative 2, I know is negative 10. Again, negative 5 is closer to 0 on the number line. It is, in fact, the larger value. So for both of these problems, I want you to notice that the value is flipped from this value. I had a less than symbol, and then both of those, the second and third problem, show greater than symbols. Now I wonder if that's true for addition as well, so let's take a look at one of those. Here I have 10 plus negative 5, which is 5, and 20 plus negative 5, which is 15. And of course I know that 15 is greater than 5. So again, I have a less than value. This one is actually the same as the first one. What I want you to get from this is that anytime you're multiplying or dividing by a negative value, your sign is going to flip. Let's take a look at what that looks like in practice when we're solving in the next example. Here I have negative 2x plus 4 is less than 10. Of course, you can see right away there's a negative 2x. That's where this negative conversation is headed. Let's draw a line down that symbol just to help us see both sides of the inequality. Again, I want to isolate my variable term. I have a plus 4, so I need to be subtracting 4 from both sides. That's my opposite operation. 4 minus 4 is 0. That's a good thing. I'll bring down my negative 2x, my symbol, and 10 minus 4 equals 6. Now this is where that idea of multiplying or dividing by a negative is going to come into play. In order to get x by itself, all the way by itself, I need to divide by negative 2 on both sides. Just like we learned before, anytime you're dividing an inequality by a negative value, you're going to flip your sign. So it used to be a less than symbol, now it's a greater than symbol. 6 divided by negative 2 is negative 3, and that gives me my solution. Now it might feel strange to flip the sign, but let's plug in a value just to check and make sure we're doing something right. We need a value that's greater than negative 3. So let's, for the sake of ease, use a 0. If I plug in a 0, I know that negative 2 times 0 is 0. 0 plus 4 is 4, and that is a value that's less than 10. So I know that I've done my problem correctly. If you need it, here's a list of steps you can take when you're solving an algebraic inequality. The only examples we haven't taken a look at yet are those with variables on both sides. So if you have an inequality with variables on both sides, you might want to look at another video and see some more examples before jotting down this process. However, for now, for these examples, the first job is to isolate the term with a variable, then you solve. Often, but not always, you'll be asked to graph. And you should always be thinking about your symbol. Is it less than? Is it greater than? And is there any reason to flip that sign as you're solving? Now remember, you only change the sign if you're multiplying or dividing by a negative. I hope this helps you get started solving and graphing algebraic inequalities. I appreciate your time. Thanks for being here, and I'll see you next time.